Thanks, Fleming, for the presentation. My name is, as Fleming said, Vlad Mihalcea. I work as a developer advocate for the Hibernate project. First of all, thanks for coming to this presentation. I hope you are going to enjoy it. This is my blog, vladmihalcea.com. On it, you can find lots of articles about Hibernate, but not just Hibernate, also concurrency control, databases, even Docker or testing, Spring, transactions, and all sorts of stuff that are somehow related to database systems. My Twitter handle, if you're using Twitter, and my GitHub account. This presentation is based on the second part of my book, High-Performance Java Persistence, which is made out of 3 parts. One is about JDBC, the second one is about Hibernate, and the third one is about Juke. I wanted to write a book about which offers a full spectrum of data access frameworks that you might want to use to cover all the use cases that you have in a typical enterprise application. For the agenda, we're going to get and discuss all these things like performance and scaling, connection providers, identifier generators, relationship batching, fetching, and caching. All of those contribute to and affect the response time. And if we target each and every one of them, we can see that the response time can be lowered significantly. So now, the first thing we're going to discuss is just some basic notions about what performance and scaling mean, and why do we want to pursue getting better performance. Well, the first thing you have to have in mind is that most applications, like this quote is from Application Dynamics, which work, and they have an application performance monitoring tool that they are building, and they realize that most of their clients, whenever they had some performance problems, most of those originated in the database. Not just the database system that's to blame, it's more the data access layer, the way you access the database, and because it's you cannot decouple the database from the data access code. You need to view it as a full spectrum. So that's why that's our target for this presentation. And performance is important not just for developers. It's also important for the business, because if for instance, if your application is working really fast, it's going to attract more clients. And you want to also have a site which is faster than your competition, because then Google is going to place it in much higher than the competition, and you are going to be in the first results. And you want to be in the first 10 results, because people don't usually go and navigate to the third or fourth or fifth page. Usually they just focus on the first results. So yeah, that's very important. It's also important not just for us, but also for the business as well. And for instance, this quote is from Amazon, and they said that every 100 milliseconds of latency, for them it costs 1% of profit. So it's very important to focus on this. It's not just a thing that you want to do it at the end of a project when you want to ship the application to production. You want to focus on this from the very beginning, because it's very important, and it's going to, if it can bring you more revenue, especially if you're a startup, you have to take it into consideration. Okay, so now the 2 basic metrics that you have for performance and for scaling are response time and throughput. Response time is the measurement of performance, and throughput is the way you measure scaling. Now, if you take a look at the definition of both two, you'll see that they are interrelated. So, for instance, the average response time, usually some people call it latency, but that's not correct. Response time is much better term. The average response time, for instance, tells you, for instance, if you have 1 second and 100 transactions, you know that the average response time is going to be 10 milliseconds. But then if you reverse this fraction, then you will see that if you execute 100 transactions per second, then you get the throughput. So those are connected. The average response time is connected with the throughput. So you don't always have to throw more resources into your system to get a better throughput. Sometimes even by just reducing the average response time, you can accommodate more load into the system. And that's a very easy gain because you target both the response time and you also get a better throughput. Yeah, but that goes up to a certain level, which is actually the response time and the throughput are you can place them in a single graph, which is called Little's law. But for the average response time in a stable system, we can say that these two are interconnected the way you see them on the screen. Okay, so now to define what affects response time, and it's much better to visualize it on a picture. For instance, if we have a typical enterprise application and we need to connect to a database systems, there are certain steps that we need to do. And if we address all those steps and if we optimize all of them, we will see that the overall response time is going to get better. So for instance, the first thing you need to do is to obtain a connection from a data source. And that takes time. Sometimes it takes more time than you realize. You also, based on that connection, you are going to prepare statements, and that also can be optimized. Using that statement, you can execute queries, and during the query execution, of course, there are things that you can also optimize both on the client side, but also on the database side. Also, traversing the result set and getting the data from the database takes time. Usually, the fetching part plays the biggest role in application performance. And then at the end, you will see that before closing, before committing the transaction and closing the connection, you also have some idle time. Some people ignore that, but if you take a connection for a very long time to do some application processing, then you are going to deprive other concurrent threads from using the connection. As you will see in a future in some next slides, the number of connection is always limited, and usually you strive to use the lowest number of connections that you can instead of the higher number of connections, because you will have to split the total number of database connection among multiple services. Okay, so all in all, if we take that picture, we can conclude that there are several steps that make the response time, like for instance, the connection acquisition time, the time it takes to submit all the statements, to execute them, to fetch the results, and that idle time. And we will go through all of them and discuss them and discuss some techniques that address one or the other. Okay, so now the next stop on our agenda is about connection providers. The thing that I mentioned earlier as well, it takes time, and depending on the database system, it varies. The time it takes to acquire a connection, it varies from 3 milliseconds to even to 50 milliseconds, and that's quite a lot if you think about it. And why does it take so much time? Is because there is a handshake. There must be a socket, a TCP handshake. There are buffers that are allocated on the client and also on the server side, and those take time. And the reason why we are using a connection, if we are using a connection pool, like for instance in the last column in this table, you'll see Hikari connection pool, and you will see that the response time for fetching a connection from the pool drops from 50 or 10 milliseconds to 10 microseconds. So below that point, it probably doesn't even make sense to lower it, because it's already really, really fast. And usually when you optimize a certain subsegment of the response time, the bottleneck usually shifts in some other part, and some other part becomes the next bottleneck that you need to address. So 10 microseconds, it's not going to be an issue anymore. But now, if you take a look at Hibernate, you'll see that Hibernate provides its own abstraction, which is called Connection Provider. Although JDBC already has two of them, you have the driver and the driver manager, but also the data source. The data source, in a way, it is a factory of connections or a connection provider. But because you also have the JDBC driver one, Hibernate came with its own abstraction, which is called connection provider. And you have multiple options. Like for instance, you can use the driver manager, data source, Hikari connection pool, or C3PO. So which one is better to use? I would say that most of the time it's the data source connection provider, because it provides you the most flexibility to use. From the application perspective, it's just a data source, it's transparent. The application doesn't need to know how many data source flavors you have mixed and chained in the end, because from the application perspective, it's just going to be a proxy. So for instance, in this particular example that I'm showing you here, you'll see that for the data, assuming we have a Postgres database, we have the PG simple data source, which is just a wrapper for the driver. It always gives you a physical connection that always establishes the TCP connection and the socket. But then we put a Hikari connection pool in front of it to provide connection pooling. And then we also put a data source proxy, which is an open source framework, which allows us to log all the statements as well as bind parameters. And it provides a lot of information, like for instance, if a statement, it was a batch or a batch execution, how much time it took. So it's very important to understand what happens behind the hood. And also FlexyPool, which I'm going to detail a little in just a few moments. It's about monitoring the connection acquisition. So from the application perspective, it doesn't matter. You're just going to get a data source, but then you have the flexibility of mixing and adding whichever data sources you want without changing the application code. That's just going to be a configuration detail in your application. So now, as we have seen, it's very useful to use a connection pool because it lowers the response time. But there's also another thing that you need to consider, and another advantage is a connection pool levels up a traffic spike. So if you imagine that you have a system like this one in this picture, and you have many front-end web nodes that are auto-scaled, for instance, maybe they are deploying a cloud solution, and then you have a traffic spike. Maybe it's not even coming from real users. Maybe there's some rogue attacker that wants to bring your system down. If you don't limit the number of connections, then during that traffic spike, the rogue attacker can just take all the connection that you have to the database, and then nothing is going to work. Because if you allow every node to take as many connections as it, in the end, you will hit the limit. So now in PostgreSQL, you have a property called maximum connection, max connections, which limits, it's a hard bound, upper bound, which after you, if you hit that limit, the server is not going to create a new connection. But then there are systems which don't provide that limit, and will probably give you the impression that you can just give or configure 10,000 connections. Usually that's a really, really bad idea, because the number of connections that you can set, it's in a way is similar to the way you set the number of threads in a typical Java application. Just because you can spin more threads doesn't mean that they will generate more throughput. The relationship between the number of workers and the number of incoming requests, that incoming request is given by the Amdahl's law, or universal scalability law, which tells you that you can increase concurrency by you can increase throughput by increasing concurrency up to a certain point, after which if you keep on increasing it, actually the response time is going to suffer. So yes, it's not just that you reduce the response time, but you also protect yourself against certain traffic spikes. So it's better to if you have a traffic spike on a given node, it's better to just increase the response time for that node instead of taking the whole system down. Now the problem is how many connections are you going to assign for each node? Because here we have a database, a Postgres database with one master and multiple slave. It's a typical master-slave replication. And then we have multiple data import applications, email sender, full text search, and auto-scaling web nodes. So how many how do you know how many connections should you assign for each of those? And that was actually a real problem that I had to solve for a real estate system that we were developing for a very large company in Finland. And because we haven't found anything, I decided to write this open source framework, which is called FlexyPool, and it's been in use by many systems throughout the world. And it covers, actually, it's a very simple implementation. It just provides you the right instrumentation into the most common connection pools like Bitronics, Atomicos, DBCP, DBCP2, 3CPO, Hikari, Tomcat, VBUR database connection pool, and it provides it collects all sort of metrics like the concurrent connections, how much time it takes to acquire a connection, how much time you lease, or how much time you hold on to a connection, the way the pool size is growing with time, and also it also has a total connection acquisition time, which takes into consideration retries and stuff like that. So you will obtain, the nice thing about it is that it's using CodaHail or Dropwizard metrics. So Dropwizard metrics offers many advantages. Usually you don't want to roll out your own metrics framework, although it sounds very easy to do. In reality, it's not as easy as you might think, because you need to take into consideration that metric data always accumulates, so you need to use some reservoirs like fixed width or exponentially decaying reservoirs. But you don't have to worry about those because Dropwizard metric already implements them. And then it has a lot of adapters, so you can export your metrics to JMX, Grafana, Graphite, to logs, or to many other systems that you need. So from this perspective, it's very, whenever you need to collect metrics, keep in mind that Dropwizard metric is a very good solution, and that's exactly what FlexyPool is using behind the scene. One nice addition, and I want to point into this graph. When you collect metrics, you should never just collect the mean time. If you take a look here on the, I'm not sure if the colors are displayed properly, but if you take a look on the orange line, it's between 0 and 1. It tells you that you need 0.5 connections, but it doesn't make any sense, because if you look on the 99 percentile, you see that most of the time you need at least 2 connections, and sometimes even between 2 or 6 connections. So usually you want, it's not like the mean or the average is not useful, it is, but usually you want the full spectrum. You want both the average, but also the 95, 99, and the max, and have all the, to have the entire histogram and draw results based on histogram, not just on averages. So this is the concurrent connection request. This is the way the pool size was growing in the application that I was monitoring. This is the connection acquisition time. If you take a look, you'll see here that we got even some transaction required 3 seconds to acquire the response time. There's a noise here. I hope you don't hear it in my apartment. Okay, so there's the connection list time. In this particular case, it was 35 seconds. So it tells you that you have a long-running connection that it's very worth investigating. So yeah, if you're using connection pool in a large system, you also need monitoring, because otherwise it's quite difficult to know what happens behind the hood. So now the next thing on our agenda, I forgot to tell you, if you have any questions, you can ask them anytime. You don't have to wait till we end up the sessions, because it's much easier if you have an idea or you want to ask something to ask it when we're there, because otherwise you might maybe you will forget it, or you'll forget the context. So yeah, if you have any question, you can just ask me whenever you want. Okay.
Anybody have any questions right now? Just keep going now.
Okay. So now the next thing on our agenda is about identifiers. This one is a very interesting topic because it's not very usually it's overlooked because it's very easy in JPA to just configure all the entities with auto and forgot what happens, and it works because behind the scene the JPA provider will choose either identity sequence or the table generator. So now we'll see how those work and how those affect performance. So for instance, if you have the identity, behind the scenes, it uses the database, a database identity column, which, for instance, in MySQL, you have the auto increment, or in SQL Server, you have the identity columns. The thing about the identity is that it's bound to a table. So you cannot have multiple identity columns per table. The thing about identity in the context of Hibernate is that you cannot know the value of the identifier without issuing the insert, and that's a problem with Hibernate, because Hibernate, when you do a persist, Hibernate, it's using the session or the entity manager as a first level cache, like a map, where it needs to store the entity as a value, and it also needs to assign a key to that particular entry. And the key is formed of the type of the entity and the identifier. So for identity, it cannot know the value unless it issues the insert. And because it has to issue the insert right when you do the persist, you cannot use batching, because by the time you hit flush, the inserts were already generated. You have to keep in mind that when you use identity, fortunately only on MySQL and MariaDB this is an issue, because on all other databases you have the option of using sequence. But for MySQL and MariaDB, for probably even for MySQL 8, which is going to come, I don't think they will add support for sequences. So in a way, this is not a problem with MySQL. It's just a problem in Hibernate that sooner or later will have to be fixed somehow. But you have to keep that in mind. Now, for sequences, most databases support them. Traditionally, Oracle and PostgreSQL have been supporting them for a very long time. And nowadays, even SQL Server support them. Now, the sequences, the way they work, the sequence is separated from the table, so you have to call it in a separate round trip. Now, if you insert 50 entries, you'll have to issue 50 additional calls to the sequence, and that's probably not going to be very efficient. But fortunately, Hibernate comes with several optimizers like pooled and pooled low. We will discuss them and show how they work. They try to reduce the number of round trips to the database. And in order to use the pooled and the pooled low optimizers, which are not backward compatible with the old ones, you need to set this configuration property in Hibernate 4 and 3. Otherwise, in Hibernate 5, it's enabled by default, so you don't have to provide it. Now, if you insert 50 entities and you increase the increment size from 1 to 5 to 10 and to 50, you will see that the response time is going to get better, and that makes sense because you reduce the number of round trips. And the next one is called table. Actually, it's a way of emulating a sequence without in a database which doesn't support sequences natively. It uses row level locks and a separate connection to make sure that the identifier is generated and it's not linked to the current transaction context, because you need to generate, because the sequence generates a new value and it doesn't roll back if your transaction roll back. So in a way, it's not linked to your current transaction. So that's exactly how it has to work also for table. But the problem here is that you put pressure on the connection pool, because you need a new connection to generate every time you want to generate a new value. And because it uses the row level locks to make sure that the sequences are generated monotonically, they are monotonically increasing, that's going to place a bottleneck on the it can place a bottleneck on the application, and as we will see, that can be a problem. So now the same thing applies also, because the table generator is emulates sequences. The same new generator mapping setting can be applied, and it provides this optimization like for sequences. So now, if you take a look here and you insert 50 rows, you will see that if you apply the optimizer, the pool optimizer with a higher increment size, you will see a performance improvement. However, if you take a look on the vertical scale, you will see that this time you have milliseconds, and for the sequence, you had like 10 times better. You have 0.35 or 0.4 milliseconds. So even with a single thread, it's going to be significantly worse to use a table than a sequence. However, if you are going to use multiple threads, you are going to see that the price you pay for concurrency is going to affect you more and more with more threads that you are going to use. So, for instance, if you compare the identity and the table generator, and you are going to insert 100 rows in MySQL, you are going to see something like that. So, for instance, for one thread, you don't see much of a difference between identity and table, but the more threads you are going to have, the much more time it will take to generate a sequence, because the bottleneck becomes the sequence generator. The table generator becomes the bottleneck because it needs to allocate a new connection, and the row level locks are going to be the place are going to become the bottleneck. So keep that in mind. What I want you to get from the end, from this section, is that never use the table generator. There are always better ways of choosing and better ways of generating an identifier than using the table generator. Now the problem is for MySQL, if you're using auto, and you have to ask yourself, which one are you going to get? Are you going to get identity or table? And the answer is, it depends. Prior to Hibernate 5, if you had auto, you would get identity by default, and that was actually good. But however, on Hibernate 5, the strategy changed, and now if you use auto on MySQL or MariaDB, you are going to get table generator, unless you are doing something like explicitly annotating the entity to use the native generator, which picks identity by default. So keep that in mind, that auto is not always going to resolve the right and the most performant identifier generator. Now, if you compare the sequence with the table, right from the start, you will probably figure out that the sequence is going to score better than the table, because the table tries to emulate a sequence, and always a native implementation is always better than one that's emulated. So now, if this is going to be on Postgres, if you take a look, I'm not sure how easy you can see it, but if you take a look on the blue line, up to 16 thread, you can barely see the sequence, but the table generator impact is quite significant. So yes, don't use the table generator, use either identity or sequence. And if you need to support multiple databases, because that's the selling point of table, the portability, you can address the problem of portability by just using sequence for most databases that support them. And for MySQL, if you need to support MySQL, you can just place in your artifacts an ORM XML file which overrides the annotation, and just for MySQL adds the identity generator for your entities. So you don't have to overwrite all the mappings. You can just overwrite parts of the mappings and just use the common ones. So that's a very good trick, and it's address both the performance and the portability issues. Okay, so that was the identifier generator. Now, related to associations and relationships between entities, in the database world, there are just three types of relationships. You can have one-to-many, one-to-one, and many-to-many. The one-to-many, all of them are based on foreign keys. usually the basic one is the one-to-many, because you have the foreign key on the client side, which is linked to one parent, and of course the parent can have multiple children. If you put a unique constraint on the foreign key, then you get a one-to-one association. And using the one-to-many association, you can create a many-to-many by placing a join table which has two one-to-many associations. So that's how you get a many-to-many. So as simple as it is in the database world, if you take a look on the Java world or the JPA world, you'll see that there's a proliferation of relationship types that you can use. For instance, for one-to-many, you have one many-to-one, one-to-many with mapped by or without mapped by. You have a child side or a parent side one-to-one. And also you have multiple ways of configuring the many-to-many. You can have, and depending on the collection type, it also can affect the performance and the queries that are generated. One thing that you need to keep in mind, because I tried to categorize them and place them based on their efficiency. The most efficient relationship in JPA and Hibernate, when using Hibernate, is always the many-to-one association. And using the many-to-one association, you can just represent any association that you might think of. Sometimes you don't even need collections because the query is much more efficient anyway, because you can paginate it any way you like. And a collection usually only makes sense if you have a few entries. One-to-many is quite a very awkward term, because the many is actually it should be something like one to few, because if you have really a lot of entries, like millions of entries or even tens of thousands of entries, you don't want to have a collection like that, because when you operate with it, Hibernate, one way or another, Hibernate is going to materialize it and fetch it, and that's going to load a lot of data that you might not even need. So the many-to-one is the most efficient one. For the one-to-one association is the one-to-one on the client side with the maps ID, because it shares the primary key and the foreign key. And the parent side is not very efficient unless you are using bytecode enhancement. And for the many-to-many, if you're using a set, the performance and the generated statements are nice and okay. However, if you're using list with order column or just simple list, which is called bag in Hibernate terminology, you will see that the performance is not very good, because every time you remove something, Hibernate is going to remove everything and add back whatever is left. So keep that in mind, that the way you choose your collection types and the entity relationships is going to affect the performance of your application. Okay, now going to batching. The batching allows you to optimize the write part. The fetching, which we are going to discuss after this one, is going to affect you the read part. Now, related to batching, there are multiple things that you can batch. But the first thing you have to keep in mind is the JDBC batch size. And Hibernate can, when you're using Hibernate, because queries and statements are automatically generated, you have this option of just switching from non-batching to batching with just one simple configuration. Because otherwise, if you're not using Hibernate, if you're using plain JDBC or any other framework like Juke, which you have to generate statements manually, chances are very, very low that you are going to develop one application and keep that in mind, that you need to use batching. So you'll probably deploy it in production without any batching and wait until the right factor becomes a problem. But then when you realize that, you'll have to rewrite it. Why? Because the API in JDBC is different from non-batching to batching. Because if you are not using batching, you are going to just prepare a statement and calling execute update. But if you want to use batching, you have to use add to batch and execute batch. So in Hibernate, if you're using Hibernate, you don't have to worry about that, because you don't need to change your code. You just have to configure the application to use you can configure Hibernate to use batching even globally. So for instance, you have two options. One is global, applied to all session because it's set on the session factory level. And the other one can override the global setting at the session level. This one was added in Hibernate 5.2. So now the global one set for the session factory, it's called Hibernate JDBC batch size. Once you set to a certain value, it will apply to any statement. So when you when you insert persist 5 entities, instead of going with 5 inserts, separate inserts to the database, you can issue a single prepared statement with 5 sets of parameters. So, and you can also override this on a per session basis. Like here, it's colored in red. You can unwrap the session from the entity manager and call set JDBC batch size and give it a different batch size value. So, for instance, here, if I'm inserting 10-person entities, and this output is from DataSource proxy, that framework that I mentioned a little bit earlier. So here it's going to tell me in the batch true tells me that I'm going to have a batch, and the batch sends only one query, and the batch size is 10. And then I see the query that it has the bind parameter values, and then I see that the parameter is going to have 10 sets for each entity that I'm inserting in the database. So if you're asking if this has an impact, it has a lot of impact if you're inserting a lot of data. Here is about inserting 5,000 entries. On the left side, where is 1 is the default when you don't use any batching. If you see that even if I increase the batch size to 10, I can see a significant performance improvement. And then the more I increase it, the performance is going to improve, but not so significantly. And it makes sense because on the left side, on where I have 1, there I execute 5,000 statements. But if the batch size is 10, then I only execute 500. So I saved 90% of them, like 4,500. But if I increase it to 100, then I will only generate 50. So I save only 450. So you can see that it's 1 order of magnitude. The number of statements has lowered. So the performance is not going to be so significant. So you will realize that usually through measurement, you will find out what's the right batch size for each particular use case in your application. But usually a good indicator is, most of the time, it's somewhere between 10 and 30 as a general rule. But of course, you have to measure in your application and just not take this decision based if you cannot measure them. So this also works for update and also for delete statements, just the same. So these settings affects all those 3 statement types. Now, one thing to consider, once you configure it for simple entity, it's going to work pretty nice. But if you are using cascading, the way that prepared statements are batched, if you have to think about that when you're executing cascading, the way the operation works, you save the parent, then you save all the children, then you switch back to the next parent, and then to children. So the way you're switching from one entity type to the other, from parent to child, that's going to issue a flush on the batch. So if you do that, only the child entities will benefit from batching. If you want to have both of them to benefit from batching, you will have to provide these 2 configuration parameters. But however, even if those are by default are set to false, if you want to use batching, it's much better to set those to true by default, because the chances that the extra CPU cycle used to order the inserts and the updates are way less of a work than how much you gain on the database side because you are using JDBC batching. So keep that in mind and also provide those as well. And also, if you're using Hibernate 3 or 4, or old versions of Oracle dialect like 8, 9, and 10, you have to know that because the driver back then had some issue related to the way optimistic locking and batching was working. The problem was that on old versions of the Oracle driver, when you were using optimistic locking and you were relying on the update count return from a batching, return from a batch update, if that return count is not consistent, you would just get some stale state exceptions which were not correct, were like false positives. So because of that, in old versions of Hibernate, the batch was disabled if the entities were using optimistic locking. It was quite a very conservative and restrictive setting, so now it's enabled by default, which is much better default these days. Also because the drivers behave much better nowadays. Now, one thing about Oracle, if you're using Oracle in your application, you have to know that you can use newer drivers with older versions because the drivers are both backward and forward compatible. So for instance, if you're using the Oracle, if you're using Oracle 10 in your on the server, you can use the Oracle 12 driver, and maybe it will not have this issue if the issue was on the client side and not on the server side. So keep that in mind, that even for old versions of Oracle, you might fix this and set this parameter to true if you're using a newer driver. And you also have to hint Hibernate to use a newer dialect, in which case you have to make sure not to jump to, for instance, to Oracle 12, because then it will probably use different syntax for pagination, which Oracle 10 and 11 does not support yet. Okay, now the fetching part. This is going to be much. There are a lot to talk about fetching, and this one is going to take a little more. Now, when it comes to fetching, there are multiple things you can optimize, and because you have the JDBC fetch size, you have to think about the size of the result set and when to choose, how much data I choose, choosing DTOs or entities. And also, it's not just that you are fetching entities, sometimes you are fetching multiple entities together because those are linked in a relationship. Now, the first one to discuss is the JDBC fetch size. This one affects every application that's using JDBC, not just Hibernate. Now, most of the time, if you're using, when you use Hibernate, just materializes and traverses all the result set and gives you the response whenever you're using get result list or a query like that, even with JPQL or Criteria API. The only difference is if you're using streaming or scrolling, but those, most of the time, those are not a very good choice to use, because pagination is performs usually much better than streaming on many database systems. And usually the way that Postgres and MySQL, which fetch the whole result set, works, that's very convenient when you're using Hibernate. However, not every database has that. For instance, Oracle has a default fetch size of 10, which is quite low, because, for instance, if you want to fetch 10,000 entries, it will require 100 database round trips, and that might take time. In Hibernate, you can raise that value globally. For instance, you can set the Hibernate JDBC fetch size property to 100, and then it will use it. It will use this value for every statement on Oracle. So if you, and you can also, that's a global setting. You can also give it as a hint as a JPA hint to the query, to the JPA query, like this. Now, if you want to think if it affects the performance or not, yes, it affects quite a lot. If you ignore the one with one, because even that can be, you could bump into that if you're using scrolling and the scroll doesn't use any batching behind the scene to batch fetch. you can end up with something on the left. But for instance, when you have 10, that you can view that, like for instance, that can be the case for Oracle, although here the database names are obfuscated. So if you increase it from 10 to 100, you can see on the graph that you get quite a significant performance improvement. So keep that in mind. For many database systems like SQL Server, Postgres, and MySQL, probably playing with the fetch size on the JDBC level is not probably a good idea. But for Oracle, it's still quite a performance improvement that you might want to do. Now, that was about how many round trips you need to materialize a result set. But then I said that I said then that we wanted to fetch 10,000 entries, but that's usually quite that's not a very good thing to do. Why would I want to fetch 10,000 entries? Why? Because if I have a UI, I cannot display so much data. I cannot have a tree with 10,000 nodes there, or a table with 10,000 rows, because it's not. It affects user experience. It also affects performance, because I have to fetch it and probably I will discard it on the UI, because there probably I use some infinite scroll or something like that. And if I'm using a mobile, it's even worse, because maybe I'm not on Wi-Fi, maybe I'm on 3G network, and the more data exchange, the bill is going to increase. So it's actually even worse for that. And even for batch processes, you will see that it doesn't make sense to use a very large batch size, because it's much easier if you use simple transactions that can roll one after the other, and usually by paginating and operating on smaller batch sizes, you can allow the database to better interleave multiple transactions than to span one transaction that takes a lot of locks and does a lot of processing and consumes a lot of resources, which and deprives other transactions from using getting their share of resources in the same way. So you have to realize that most of the time it's a very good idea to use pagination, both for batch processing and especially for UI application. So setting the first result and max results is quite a good thing to do, because it affects the number of entries that you select in one window. So for instance, the difference between 1,000 rows and 100,000 rows is quite significant. It's quite a lot, depending in any database you are going to use. Because why? Because you need to, if you select a lot of data, there is a very low chance that you are going to use an index, because when you select a lot of data, the database will recognize that it's much easier to scan the whole table instead of just using thousands of random access operations, IO operations, even if it would use an index. So it might not use an index. You have to load a lot of data. You have to load it from the memory, into the in-memory pages in the database, and then send it over the network into the result set object. Then you create the entities or DTOs, and then you select over the network also to the browser as a JSON, another transformation, and then it goes to JavaScript. You pick two rows and then discard everything. So yeah, you waste a lot of resources, and the application is running really bad, and you don't want to have that. And if you develop your application with pagination right from the beginning, you will see that the performance is going to be predictive with time, because with time the amount of data is going to increase. Otherwise, if you don't place any limit, the more data you accumulate in the application, the more data is going to be selected by a certain query, and the application is going to perform worse and worse. And at some point, you have to intervene and just add the pagination, but that will require code changes, more testing, and so it's better to start with pagination right from the very beginning. Okay, so now when it comes to pagination, the default, which is used by this, which is defined by the standard, is called offset pagination. Offset pagination for very low, if you can restrict the number of entries and the result set to, for instance, to 100 or 500 entries, and you need to paginate those, the offset is not going to be a very significant performance issue. The only problem is if you insert data in the middle, that offset is going to take that into consideration. So you see skew result from one page to the other. So if that's not an issue, usually offset is quite okay. But if having consistent pages is very important, or if you cannot restrict with your predicate the amount of data that needs to be paginated and scanned by the index, then offset is going to perform worse towards the end of the data sets, like when you hit the, I don't know, the 200th page. So then you have two options. Either you limit the number of pages, like for instance Google does. You only have like 10 or 15 pages that you can use. Otherwise you have to narrow down your search with much more restrictive queries. Or for instance, you can key set pagination, which takes into consideration the primary key and the key that you're using for the order by, because every pagination might use a order by, because the SQL statement does not guarantee any order unless you give an order by. So you always have to use some sort of ordering whenever you are paginating. So yeah, if you want to learn more about key set pagination, you can see Marcus Vina on the site, Use the Index Look, and his book SQL Performance Explained, which gives you much more detailed about this key set pagination technique. You will learn there that offset pagination is extremely bad and should never use it. In reality, there are use cases when it's not really that bad. If you, as I told you, if you can restrict that, the result set can be filtered by your predicate filters by the where clause, so that it doesn't have to scan a lot of data. So if you have that, then it's not going to be an issue. Another optimization is, like, for instance, we didn't even use the database for pagination in our real estate system we implemented in Finland. We just used Solar with Lucene, which was doing all the pagination and all the searching, free searching, and was actually working much faster than Postgres with indexes. So yeah, sometimes you don't even have to use a database for that. Now, also, it's not just the number of records, which is on the vertical of the table. It's also on the horizontal dimension, the number of columns you select. On top, you have the select all, which is a typical entity query, the way it's done by Hibernate or JPA. And below you have a custom projection, which only selects a single column from this query, which has multiple joins. If you compare them, you will see that the number of columns gives you a lot of additional work that you might not need. So for instance, here is just 15 columns compared to 1 column. But if you have a lot of joins and large entities, you can have, instead of a projection with 3, 4, or 5 columns, you might end up having fetching 50 or 60 columns. That there's a very good chance that on the UI side you don't need them, so you have to discard them anyway. Now, one extra advantage of using a custom projection is that, for instance, you might use a covering index, which does not need to scan the pages, so it can give you the result right from the index instead, and without any extra additional I/O for reading data, which is not the case for when you're using select all. So yes, it's not just the pagination, but also how much data you select by the number of columns. So now you have, and you've been having DTO projections in Hibernate for 10 years at least, probably. You have the option of using that select new and the constructor projection you have in JPA, but for much more complex results, DTO results, you can use the Hibernate specific result transformer. You can actually build recursive trees with that, and or you can even you can select DTOs which are formed in parent-child associations. So it's a very flexible structure which we are going to optimize in Hibernate 6. We want to make it a functional interface. So don't get scared if in Hibernate 5.2 it's deprecated. It's deprecated, but it's going to have a replacement because the concept it's really great. So DTO projections are very good for when you have a read-only view which you don't plan to modify. Use DTO projections, like when you have analytic query reports or tables that don't necessarily need to be changed at all because you're just viewing them. Now, entities, on the other hand, when using JPA, on many projects, or actually on most projects that I've seen, people use entities because it's very convenient to just fetch entities on your development machine. You will not feel the pain that's going to be a problem. But when you go into production, you realize that you're fetching lots and tons of data with your entity queries, and that's a bad thing. Now, entities are only needed if you plan on modifying those results because you want to benefit from the dirty checking mechanism. And also they are very important because they bring you optimistic locking and application level concurrency control, which otherwise you would not have them. So for writing data, they provide a lot of value, but just for reading data without planning on modifying them, it's just waste. Okay, so yeah, the last thing about entities is about relationships. Not only whatever I told you by now applied to a certain entity, but in JPA you have also the option of fetching more entities at once. And unfortunately, in JPA 1.0, the many-to-one and the one-to-one association were set to be fetched eagerly by default, and in many applications they are simply left like that, and that can lead to a lot of performance issue, N+1 query issues if you forgot to add them in every JPQL query. Otherwise, Hibernate will just have to issue secondary statements to initialize them. So keep that in mind, that most of there are rare cases, there are very, very rare cases where you really need to use an eager association. Most of the time, all associations need to be lazy and have on a per query or business use case, because a fetch plan, an eager fetch plan, when you do it during the mapping, it's like during the mapping, you dictate the way you are going to fetch data for every use case you have in your application, which is quite impossible because only during a particular use case you know how much data you want to fetch, and each use case is different, has different footprints on the data. So eager association usually are a cause of many performance issues. So keep that in mind and don't use them. Even for 2-1, for too many, they're actually even worse. But luckily, those are lazy by default. Now, if you're using lazy, you're using Hibernate, you are going sooner or later you are going to bump into the lazy initialization exception. On Eclipse Link, you don't have it because they just mask it for you. But that's not actually a good thing to do, because the lazy initialization exception is like a code smell that you're doing something wrong. So there are good ways to fix it. Like good ways are just using the fetch directive and fetching just the data during the query or afterwards with Hibernate initialize, or using entity graphs or the fetch profile, but just doing it explicitly so that even the next developer knows that you really want to fetch that particular association. Otherwise, there are also bad ways of addressing the lazy initialization, like this open session in view, which is an anti-pattern, but some people still think it's a pattern. Well, it's not. The problem with open session in view is that the transaction part only happens during the post service, and there you can have multiple statements executed on the same connection. Afterwards, the connection is closed because the transaction is closed, but the session remains open. So during the UI rendering, for every new association that needs to be initialized, you are going to go and fetch a new connection and open a new transaction. Most of the time, that's not going to be a read-only transaction, so we're going to put pressure on the transaction log as well. So that's very bad because you put pressure on both on the connection pool, the transaction log, and overall it's much more difficult to optimize such a system where the responsibility of fetching data is split and scattered throughout multiple layers. So yeah, that's very difficult to optimize. It's performing very bad. This is not just me. I've been told even by other people that had this problem. I had this problem in one project that I worked on, and we had to replace this with what I said to you. So this is not just theory. This is actually practice. I've been burned by this, so it's not like I've had other experience related to it. But there are other people who shared my feelings as well related to this anti-pattern. So yeah, don't use that. Another anti-pattern, which is actually, this is Eclipse Link. The way that Eclipse Links work, you can make Hibernate work exactly like Eclipse Link by setting this property to true. It's false by default. It masks every lazy initialization exception. How when you close the session, you have the proxies which are not initialized. So by the time it has to initialize them, Hibernate will just open a temporary session, which in fact opens a new connection and does the same thing like open session in view. Instead, it's actually even worse than open session in view, because instead of reusing the session, you actually open a new session for every association. So it's going to perform even worse. So yeah, don't do that as well. Now, the last part on the agenda is related to caching. Now, I'm not only going to talk about the second level cache, because in an application you have multiple layers of caching, and usually this is a trade-off between consistency and performance. One of the best thing to do and to configure right from the start is the shared buffer in the database. The database has been evolved, or the relation database has been evolved to try to bypass the I/O and the disk as much as possible, and to use all the data the hot data to store it in memory, because it's much easier and much faster to load data from memory than from the disk. And for instance, that allows, for instance, SQL Server to run allows Stack Overflow to run with just 2 SQL Server nodes and to serve billions of queries per month. Because every time you do something in Stack Overflow, you just go to the same SQL Server instances. So think about it. If a site which is number 47, I guess, in the world can use only 2 nodes, it's quite remarkable what you can achieve with enough memory, if you can store as much of your database in memory and serve all the traffic from memory instead of going to the disk. So if you have an application configuring the shared buffer, they are called shared buffer, or they have different names based on the database. Some call it buffered pool, and some have multiple buffer pool. For instance, in Postgres, you have shared buffer, but also have the operating system cache, which the Postgres system relies on. So keep that in mind and configure those because they can improve performance quite significantly without affecting consistency. If you move, the more you move from the database, the more you are going to lose consistency, because it's much more difficult to maintain it. On the other side of the spectrum, you have the application level cache like Hazelcast, Memcached, Redis, where you can just store entire aggregates in the cache and bypass bypass the network between the application and the database entirely, and bypass all the data I/O that's done, and also the query, the execution plans. So of course, it's going to be much easier to serve one aggregate in a single request response, which is O1 instead of it can be very complex. Even if you're using an index, it can be O log n. So yeah, an application level cache provides a lot of performance, but you have to pay the price for consistency. Now, the second level cache is somewhere in the middle. It provides good performance, but it also provides you with means of maintaining strong consistency. So it's a very convenient, but not in every application, because most of the time you still need to configure the database cache. And for many systems, enterprise systems, you probably don't want to run in production without an application level cache, because, for instance, on application level cache, if you can work in read-only mode, you can take the database down for maintenance, or if it crashes for some particular reason, or just level up traffic spikes if you have them. So having an application level cache and duplicating data sometimes is used also for resiliency, not just for serving data as fast as possible. So now the goal for the second level cache, and the biggest applicative for it, is to use it on the master node, because if you have a master slave replication and use the second level cache, you can offload the master load. So instead of serving some select queries, it can load some data from the cache instead of serving it from the database. So that's where it makes sense to use the second level cache. Now, the reason why consistency is important is because, as we know, there are two things hard in computer science: naming things and caching validation. So because of that, the second level cache is appealing. It has multiple levels or strategies, how they are called. Not all of them are strongly consistent. Transactional is strongly consistent, but you have to use JPA. So it provides much lower throughput than read-write, which is also strongly consistent, but it's using some soft locks. And non-strict read-write, as its name implies, it's not. It might get you into some inconsistency. So depending on your use case, if it's not a problem, then it's worth using, because it provides a better throughput than the other two. And read-only, read-only is not always very useful, because if you have a lot of read-only data, you can just store it in the application level cache and not have to store it in Hibernate. Okay, so also besides the entity level cache, you also have a collection cache. Entities in Hibernate are not stored as entire aggregate. They are stored in a normalized fashion. Each entity is stored in its own region. And then you also have a collection cache, which stores the identifiers which are linked to a particular parent. If the read-write or transactional cache can be write-through, the collection cache can only be read-through. That means that every time you make a modification to the collection, you have to invalidate it and repopulate the cache on the next read. Now, the reason why the second level cache offers you an advantage over an application level cache for some aggregates is, for instance, if you consider this aggregate where you have a post which is linked to a board, to tags, comments with user votes, page views, social media counters, and you cache all of them. Now, imagine that you cached, like, for instance, you have a Reddit application and you store thousands or tens of thousands of posts that you cache because you are a very successful site. So now you realize that you need to change the board name or tag name, which affects thousands of entries. In Redis or Memcache, you'd have to just because you cannot update them with a query, you have to either modify the entries or invalidate them and repopulate them once again. But then if you invalidate a lot of data and try to repopulate it at once, you will put a lot of pressure on the database, so you don't want that. Otherwise, you'll have to to split that operation and to have it running over a large period of time in which you will not benefit from the caching. So because of this invalidation ripple effect, makes sense. It makes sense to use the second level cache, because in the second level cache, each one of those is stored in a separate region. So once you modify a tag, you will modify only one entry in a single region without affecting the other ones. But if you're using the collection cache and the entity cache, then you can fetch an entire aggregate right from the cache without having to go to the database, or just going with minimal read operation. So bear that in mind, because the second level cache can be very useful, but it's not a global solution to performance problem. It can help, but only if used appropriately. So you also have to monitor that as well and make sure that you have a very good cache hit ratio, because otherwise, if the ratio is not very good, then you might have to reconsider if the cache is not actually adding overhead without too much benefit. Okay, so now we can answer the questions. Before I answer them, you should know that I also give you a 33% book discount by applying this coupon, which is colored at the end of the URL of my book. Fleming can also send you this URL if you want after the presentation. Now, if you have questions, please raise them, and I will answer all of them one by one.
Thank you very much.